Welcome to the Heat Conduction Lab. You have the option of performing number 1, heat conduction, or number 2, Angstrom's method. In number 1, part A, we'll be finding rates of heat flow in brass, aluminum, and stainless steel.
To start, turn on the function generator and set its maximum to 8 volts. Attach the 2 leads to the heat conduction apparatus, making sure to connect the positive terminal to red. Also, connect the heat conduction apparatus to the temperature array by means of the 9-pin cable, and in turn, attach the array to the GLX. Finally, connect the GLX to the computer via the micro USB cable.
Measure the distances between the thermistors for each bar.
Set the apparatus to heat and place the insulators on the bars.
In Data Studio, click Setup and verify that the temperature sensor sample rate is set to 5 Hz. Double-click Graph and select T1. You will need to drag T4, T5, and T8 into the graph window to display all 4 traces on the same graph. Collect a test run of data to ensure that all 4 sensors are at room temperature. Set the power supply to 5 volts DC and start recording data. Allow the system to heat for 5 minutes.
Once data collection is complete, turn the power supply back down to 0 volts and remove the insulators to allow the bars to cool.
In part B, we'll be measuring and comparing the speeds of heat pulses in different materials.
Ensure the switch is set to heat and place the insulators on the bars.
Click Setup and set the sample rate to 2 Hz. Create a graph that displays T1 and T2 and collect a test run to ensure that data is being collected properly. Note that it is not required to start the section from room temperature.
Set the power supply to 5 volts and begin recording data.
Wait until T2 reaches 40 degrees Celsius.
When you reach 40 degrees, turn the switch to cool and begin timing. Every 30 seconds, switch between heat and cool. Note that this will result in a period of 60 seconds and that it is also possible to perform the timing by watching Data Studio instead of using a stopwatch.
When the amplitudes have stabilized, press stop and turn down the supply.
In part C, we'll be measuring wavelengths and speeds of heat waves in different materials.
Turn the power supply to the triangle wave setting. Ensure the display reads 8 volts for the maximum voltage. Press and hold the set button and ensure the display reads 0 volts for the minimum voltage. Press set once and set the period to 50 seconds. Hold set and ensure the display reads -0 to indicate that the triangle wave will ascend and descend linearly.
Press start and ensure that the function generator slowly approaches 8 volts and slowly descends rather than starting again immediately from 0.
Set the switch to cool and place the insulators on the bars. Press start on your power supply and also in Data Studio. Note that you will want your graph to contain traces for both thermistors in the wide brass bar, namely T1 and T2. Wait for several minutes until both waves have stabilized with a constant amplitude. Delete that run and start a new run, ensuring that you collect at least 2 full cycles.
Stop the power supply and change its period to 100 seconds. Repeat part C for the new period and explain its effect.
If you choose to do experiment 2, you'll be measuring the thermal conductivities of 3 different materials.
Set up the apparatus as shown in experiment 1 and set the switch to cool.
Set the power supply to 8 volts triangle wave. Hold the display button to ensure that the minimum voltage is 0 volts. Press display once and set the period to 30 seconds. Hold display again and select -0 to ensure the proper waveform.
Press start and ensure that the function generator slowly approaches 8 volts and slowly descends rather than starting again immediately from 0.
In Data Studio, create a graph with traces for T3 and T8, the 2 thermistors in the aluminum bar. Press start on your power supply and in Data Studio.
Wait several minutes until the amplitudes have stabilized. Delete that run and collect a new run with at least 2 full cycles.
Repeat this 2 more times so that you have 3 runs of data.
Collect 3 runs with a 40-second period and 5 runs each with periods of 50 seconds and 100 seconds. This will provide all the data you need for parts A, B, and C, but note that you will need to look at the brass thermistors for part B and the stainless steel thermistors for part C. Thanks for watching the Heat Conduction Lab. We hope this lab dispels the myth that physicists aren't cool. In addition to electrically cooling our sample, we went to 4 bars in this experiment.